All right, page 229 in your textbooks, you had the practice, numbers 13 through 15, and page 250, number 15. Starting on page 229, though, numbers 13, 14, and 15, you were solving systems of equations, and one of the equations had a square in it, or possibly both equations would have had a square in it. What do we call equations with squares, class? Quadratic equations, and up till now, the only quadratics we'd ever looked at had been quadratic equations that were graphed as parabolas. But remember yesterday I showed there's actually a number of different quadratic shapes you can get. You get hyperbolas, circles, ellipses, parabolas, all kinds of stuff. And so let's see how we did with the practice 13 through 15. Obviously my first equation, this is just a linear equation, a straight line. The next equation has just one variable squared, and that's going to be a parabola then. The important thing to remember is when we solve a system of equations in which one is quadratic, the other often not, we generally need to solve using what method, Brandon? Substitution. The substitution method. So here, what variable would be best to substitute for? X. We could, but then I'd have to square something. Square the first square, I don't want to square stuff. I would double switch here and rewrite the top equation as
x plus 2 equals y.
Well, it wouldn't be plus 2.
Minus 2, yeah.
Okay, x minus 2 equals y. That way I can just put the x minus 2 right here. Rather than solving for the x, right, 2 plus y, and then I have to square the 2 plus y, 4 plus 4y plus y squared. Don't want to have to do all of that. So here that makes it a little easier. So the bottom equation then would become what, Abby?
It would become x squared plus x minus 2 equals 18.
There we go. And then from there, since we've got our quadratic equation, we would then
So
by
moving the 18 over as
to get negative 20. And then from there, Genesis. No, we don't want to do that. We want it set equal to 0 so that we can factor. There we go. And so we factored into
x and 4 and 5. Oh, plus and minus. Switch the sides.
Yeah, switch the sides. We actually want the 5 to be the plus and the 4 to be the minus. So we have the two x values, Michael.
X negative 5, x plus 4.
But negative 5 and positive 4 my x values. Now again, this is not a point, negative 5, 4. These are two separate abscissas, meaning we have at least two separate points. Now, remember yesterday, we worked a problem where we had, I think it was 2 ordinates. And we tried to plug them in. Each ordinate actually had 2 separate abscissas to go with it. So it's at least 2 points. It's possible one of these may produce more. Of course, we're going to see that's not the case, right? We plug in the negative 5 class, we get negative 7. We plug in the 4 class, we get 2. So it is just, each x has just a single y with it, and there's our points. How many have these 2 points on 13 for the points of intersection between the line and parabola? Most of us, okay, just a couple of you did it. Questions from those who did not have this. Did you get the y by itself and substitute there, or did you get the x by itself and substitute?
I got the y.
You did get the y by itself, so you did it this way, just found a mistake as you were going?
Yeah, I got 4, 2, but I got negative 9, negative 7.
All right. Question?
I tried to do the add 20 on both sides.
I got you. Instead of doing the factoring once we set equal to 0. Okay, so good reminder for us. Let's take a look at number 14 then. We have a negative x plus y is equal to 5, and then x squared at negative y is equal to negative 5. Now, technically, although the best way, most commonly, to solve these equations is by substitution, you could, if you're careful, solve by addition as long as there are at least some like terms lined up, and there are. Do we see that the positive negative y are lined up? So I could add if I'm just careful. You realize these would cancel, these won't, right? They're not like terms. What would you get if you try to combine a negative x with a positive x squared? X squared negative x, or negative x plus x squared, but I like this better. We could also add here the 5 in the negative 5 class, 0. So you don't have to do substitution. Similarly here, I could have canceled to get x squared plus x equals 20. All right, so if you're careful with it, the downside of that is oftentimes a student will say, oh, these cancel too. Well, no, an x doesn't cancel with an x squared. So we've got our quadratic here at this point, regardless of the way in which you did it, right? You could have said y is equal to 5 plus x and put a 5 plus x in right here, right? X squared negative 5 plus x equals the negative 5. X squared negative 5 negative x equals negative 5, and allow those negative 5s to cancel. It gets you to the same point, right? Once you get here, Maddie, what should we do?
Well, you can take out x.
Good. I do factor, but I don't backwards FOIL because I don't have 3 terms. But I can have a common factor that I pull out to leave me with. And so I've got 2 factors, just like here I had 2 factors. And we're not used to showing the equals 0 on both of them and moving that over to get the 4 and moving that over to get negative 5. We just kind of do it in our head. Well, here we set each factor equal to 0. This first x class really equals 0. And the second one, of course, equals positive 1. We can go back to one of the originals, or since I already rearranged this one, plug in a 0 class. What y value goes with 0? 5. So 0, 5 is one of my points, and then plug in a 1, 1, 6 would be the other. You didn't have to solve it this way. Obviously, you could have solved it the other way as I pointed out. Should have gotten to the same point, though. How many got these 2 points for number 14? Ooh, only one of you. Questions? How many threw you off when you got the 0? And we get the 0, it's like, now what do I do? Remember common factor, still is a way of factoring. Let's take a look at number 15 then, where we had an x plus y is equal to 4 and an x squared plus y squared is equal to 6. Now here, there are no like x's or like y's, right? There is no addition possibility here. I've got to solve, Kendall, by... And, I mean, really, there's not a clear best choice. They're about the same, so just pick one. So rewrite to get?
X equals 4 minus y.
And then we're going to take the 4 minus y, plug it in here, but we've got to square it. What do we get when we square the 4 minus y, Kendall?
16, negative 8y, positive y squared.
Good. And then we still have all the rest of the equation. That was just the x squared, or the 4 minus y squared. So we still have the plus y squared is equal to 6. At this point, Brandon,
You combine the y squares.
to get...
2y squared.
And then we'll go and make descending, so then keep the...
Negative 8y, and then move the 6y's to negative 10.
To get what?
Positive 10.
Positive 10, there we go. All equal to 0. And I could even make my life a little easier if I wanted to, Abby.
Factor out of 2.
Yeah, or rather than necessarily factor out a 2 and then setting the 2 unequal to 0, just take a 2 out of everything, including the 0, to get...
Y squared minus 4y plus 5 equals 0.
And backwards FOIL, and the y squared class, y and y, positive sign, negative, negative, split a 5 into 1 and 5 or 5 and 1, check the outer inner. No. There's no other way to factor that though, right? Well, if you can't factor, class, you can always complete the square or use the... Though here, if you go to the form that Abby gave us, completing the square really wouldn't be too bad, because I've got a 1, and I've got an even right here. So all I have to do is kick the 5 out here, y squared negative 4y equals a negative 5. What would have to go in the gap right here? Audrey?
16.
Careful, half and square, remember?
4.
4. And if I put a 4 on one side, 4 on the other side as well, this y squared minus 4y plus 4 can turn into what, Genesis?
1 plus 2y.
Ooh, careful. Perfect square trinomial?
Oh, y minus 2.
There we go, y negative 2 squared. And on the other side, the negative 5 positive 4 class, negative 1. What should I do next, Michael?
Take the square root.
Yeah, square root of both sides. Of course, the square root of y minus 2 squared is y minus 2. And what is the square root, or rather, what are the square roots of negative 1, class? Yeah, this is positive negative I. Sorry, my negative kind of got covered up by the radical sign, but positive negative I. So what are my 2 y values? What are my 2 ordinates, class? Well, what are the 2 ordinates, supposedly? Positive negative I plus 2, or remember, generally in the, for complex numbers, we put the real before the imaginary. But the point is, It's complex. There's imaginary. And we said yesterday, if any of your values are imaginary, that would mean no points of intersection. This line and that circle never actually intersect. How many came to that conclusion? You got the imaginary somewhere and realized, I don't have any points of intersection. All right, questions on this? Questions on this? All right, let's take a look at page 250 now. Page 250, number 15. Solving a system of 3 unknowns. Again, as many unknowns as you have, that's how many equations you need. So theoretically classified 5 variables I was solving for. How many equations would I have to have? I'm not going to do it to you, but if I had 5 unknowns, I would need 5 equations. Yeah, so 3 unknowns, 3 equations as far as we're going to go. You understand the process for 5 would be you'd have to pick a variable to get rid of multiple times to get it down to 4 equations. Find a variable to get rid of, work it down multiple times to get to 3 equations. Pick a variable to get rid of, work it down to 2 equations, 2 unknowns, and then you can solve from there. Such an annoyance, okay? But you know the process. You'd be able to build on it if you absolutely had to. Pray you never have to. 9x, positive 6y, positive 2z equals 17. We had a negative 10x, negative y, positive 3z equals negative 5. And an x, positive 2y, negative z is equal to negative 12. I only see one variable I really don't want to get rid of, class. X, big numbers. Y wouldn't be too bad, because I could do a 3 here to match the 6, but I mean the z just is begging to be eliminated. How many did get rid of the z? Y? Okay, let's see, not X, please not X. All right, I'm going to go with the z, so apologies to Maddie. I'm going to go z here, and I'm going to start with which 2 equations, Genesis?
I did the first and third.
First and third. I like first and third because all I have to do to the bottom here is multiply by 2. So let's keep the top equation for now, the 9x plus 6y plus 2z equals 17. What does my bottom equation become, Genesis?
2x plus 4y plus 2z equals negative 25.
Good. By the way, remember, make sure we multiply all the way through. She did a great job there, but that's a common mistake. In fact, that's the first thing I look for. If something's not working out, I'm like, did I multiply by the constant at the end? Because that's an easy thing to miss. And when I add the equations together, I get a happy new equation. What is my happy new equation, Kendall?
11x plus 10y equals 7. Negative 7.
There we go, negative 7. Frankly, that's not such a happy equation, but at least it doesn't have z in it. All right, now we need to do the same thing again, but 2 different equations this time, Maddie. Let's go second and third, though this time I'm going to want to multiply the bottom by 3. Okay, so again, we'll keep the middle, the negative 10x, negative y, positive 3z equals negative 5. 3 through the bottom. By the way, just in case you were wondering, quizzes and tests, it doesn't matter which variable you get rid of. I'll grade you based on how you do it, so it's not like you do it different from me or wrong. Cancel away the positive negative 3z. What happy equation are we left with? Okay, that's not too bad. At first I'm like, this is ugly also, but the y's give me hope. So we've got our 11x, 10y, and negative 7. In fact, because of that, let's put a 2 through here, Michael. Instead of rewriting this, let's just go ahead and put the 2 through right now.
Negative 14x positive 10y equals negative 82.
All right, and also need to change the signs of one of these. Let's go bottom because that gives me a positive, which I like, the negative, which is going to cancel anyway, and then this positive. So here we'll have
25x
is equal to
75.
Oh, that works out great. X just equals 3. Now what do I need to do, Brandon? I've got my x.
Plug it back into the equation.
Which one? One of the 2 happy equations. Yes, which happy equation?
11x.
All right, so we'll plug in the 3 right here. We'll get,
33.
and then what do I do with the 33?
We'll go raise the negative.
To get 10y is equal to,
Negative 40.
and therefore, that's not bad at all. Y equals
Negative 40.
negative 4. And then finally, Abby.
You can plug those into the bottom equation.
Good with sad equation, but it's not too sad, I guess. We'll plug in the 3. our negative 4 ends up actually giving us here a
Negative 8.
-8. Don't lose the fact that it's a minus z. That's going to be important. All equal to negative 12. We can combine.
Negative 5.
Kick it out as a
Positive.
to get negative z equals.
Negative 7.
So therefore z just equals.
7.
So our answer is going to be, Audrey,
7.
that's z, but what's my answer for the whole system?
3. Negative 4. 7.
There we go. And how many had the correct answer? All right, 3 of you. Questions? Questions, now that we've seen it work. As we were working, if you didn't get this, were you able to find your mistake? All right, so you found yours, able to find, no idea? All right, no idea where yours was either. Both of you got rid of the z, like I had said.
Actually, I think I got rid of the y.
Oh, you got rid of the y.
Yeah. Well,
Yes, you did. Where is your work?
right there I had equals 89.
So somewhere earlier is where we had our
I think-
issue.
Oh, it's negative 7. That makes sense.
Ah, okay. And then for
huge
yours,
numbers, and I think I confused myself.
very scary, sad numbers. All right, so you did a 6 through the middle. All right, and then you did a 2 through the middle. Should be negative 22 right here. I'm not sure if that's the only mistake, but that's one mistake I'm seeing. Had you put the 4 through with the 22, that would have been an 88. Would have given you a 75. Yep, that's the problem. All right. Negative 10, negative 12, negative 22. All right. So everybody, and you two guys had already found it, so we're all good to go on this. All right. Go ahead and close your books, and let's work some problems together now that are not in your textbook. Good kind of an overall review of these systems we've been working on. Looking at an exam coming up Friday. Yesterday I mentioned that's in lesson 133. I can't do basic math. It's in lesson 134. So anyway, if you would go and copy down this system, x thirds minus y halves equals 13 thirds. And 4x fifths plus y thirds equals to 64 fifteenths. What do we need to do here, Genesis? Yep, and multiply the top everything by, and the bottom everything by. And what does my top equation become when I multiply to 6?
Minus 3y equals 78.
Ooh, careful. Cancel first.
Oh. 26.
There we go. Again, those little mistakes throw us off later. Let's put the 15 through the bottom now. Audrey?
12x plus 20y
Ooh.
plus 5y.
5y.
Equals 64.
There we go. Let's see now what, Michael?
Cancel the x's.
All right.
Multiply the top by 6 to get 12x. 18y,
Negative
negative 18y.
You got it.
And 52.
Ooh. You're putting a 6 through the top, you said. A 6 times 26?
I did 6 times 12. 156.
There you go, 156. Bottom equation for now, I'm going to write the 12x plus 5y equals 64. Really kind of a toss-up here. Where do you want to go with the negative?
Bottom.
Bottom? All right. And what's that going to give us next, Maddie?
Negative 24 equals 92.
All right, and that gives us a nice even answer, actually. We don't know our 23 times tables, but it's there. Y equals anyone? Negative 4. Where do I go to get the x value, though? Kendall?
When change equation.
Good. Usually you go to the original, but not when there's the ugly fractions. We're going to go to one of these initial changed equations, and let's go with the top one has littler numbers, and the -4, -3 gives me a,
Negative 12. Positive 12.
which is going to become a
Negative
-12 when we move it over. That's going to give us a 2x equals,
14.
and therefore x equals anyone 7. So our answer is going to be, class, 7, -4. Questions on that? Do we feel like we're good on these? I know we did it together, but does everyone feel like, yeah, I got these fractional equations, just knock them out, just be careful? Any questions? Write this down if you would, please. 3x is equal to 2y plus 8, and 4y minus 6x is equal to -16. And let's have Audrey start us out.
We can move the 2y plus 8 over.
Okay,
I mean, just the 2y
all right.
to get 3x minus 2y equals 8.
All right, for now, let's leave the bottom at, ooh, well, no, let's not leave the bottom as is, actually.
-6 x plus 4y equals -16.
All right, so kind of rearranging to get the like terms lined up here. Brandon? Take out a 2 across the bottom. What does that give me if I take out the 2?
-3x positive 2y -8.
All right. Some of you might have been thinking multiply the top by 2, but you know it's going to have the same result. Thoughts?
It's not looking cancel.
Everything cancels. Literally, my statement here would be, class, 0 equals 0. So what kind of equations are these? They're a perfect match. Dependent equations gives me an indeterminate solution, right? These lines are coincident, all kinds of terms to keep track of as we think about the exam on Friday. What do I do with an indeterminate solution like this, Abby?
You plug in t for one of the variables.
Good, I'm going to plug in a t for one of the variables. We call the t, class, the parameter. And which variable do you want to plug it in for?
Y.
The y? All right. And so I'm going to go to one of my originals. I'm going to go here, and instead of a y, we're going to call it t, which could be any value. The x then is going to equal what, class? 2t plus 8 all over 3. And this describes every single point that lies in those coincident lines. Questions on what to do with an indeterminate solution brought about by dependent equations. Do you remember how to work with the parameter? Questions? All right. Write this down. mx plus ny equals r, and nx negative 3y equals w. We would describe these equations, class, as being literal equations. Good. And here we're not going to use substitution. We're going to have to go with elimination, but we're going to have to do it twice. And walk me through. What do we need to do first, Michael?
You need to multiply the top equation by -3.
Do I want to multiply by -3?
I don't know.
Well, we want to make the top become what? Want these both to
by
become...
3.
Yeah, just by the 3, because if you multiply the negative, now they're not going to have opposite signs. So we've already got the opposite signs. Let's just put the 3 through the top to get
3mx plus 3my equals 3r.
all right, at the same time through the bottom, let's put in
an n
to get
nx.
nnx.
Yes.
Instead of nn, let's say
I copied it down wrong.
okay.
N squared x minus 3ny equals nw.
Can you imagine copying something down wrong?
Ha.
Brandon laughs you to scorn. All right, now what do we need to do, Brandon? Add them together to get?
3mx plus n squared x equals 3r plus 3w.
All right, hold on just a second. And once we've added the 3mx and n squared x to get 3mx plus n squared x, what am I going to do on the left-hand side now?
Pull x.
Pull out an x. Now again, you could do this without writing this down. You could say, well, I know I'm going to pull the x out, and I know what's going to be left in parentheses, Brandon.
3m plus n squared.
3m plus n squared. So we could have skipped this step and gone straight to this. Obviously, we know the next thing we're going to have to do, class, is divide on both sides. Let's just do the division in our head, so to speak, and write our answer for x. Kendall?
3r plus n 3m plus n squared.
All right, now that we've got our big ugly x answer, we need to go through and get our big ugly y answer. How do I go about getting my y answer, Abby?
You do the elimination for y.
Good, eliminating the x to get the y. So now we're going to multiply the top equation by n and the bottom equation by
m.
m. And we already see, since they don't have different signs, we're going to want to change the sign somewhere anyway. Let's make it a negative m and just be very careful as we distribute. Top equation is going to become what here, Abby?
M x plus n squared y plus nr.
Equals nr?
Oh, yeah, that's what I meant.
All right, and then in the bottom equation, that's going to become what, Audrey?
Negative mx positive 3my equals negative mw.
And again, allowing us to do this the quick way, we'll cancel the mnx, negative mnx. What should I write for my y's here? Maddie?
You can go ahead and put y.
Good, to get
N squared plus 3m.
there we go. And then on the other side. And so what is our answer for y? Genesis? She gets all choked up. She loves math class.
Minus m w over n squared plus 3m.
And there we go. Any questions on literal equations? Again, we're just basically kind of going through hitting every special goofy thing we've seen since we talked about systems. Any questions on literal equations in our systems? All right, write this one down. 6 over x plus 5 over y equals 8. 6 over x plus 5 over y equals 8. And then also 2 over x minus 4 over y equals 14. 2 over x minus 4 over y equals 14. Variables in the denominator. What are we going to have to do here starting out? Genesis? Saw you mouthing something over there. Substitution, right? The UV substitution. And what do we get when we make that substitution, Genesis?
6u plus 5v equals 8. 2u minus 4v equals 14.
The only key to working with the UV substitution is once you get your U and V, do not stop. I'm not asking you to solve for U and V. I need X and Y. We're going to use U and V as a means of getting there. So just a quick reminder there. Now what do we need to do, Abby?
You need to multiply the bottom by 3.
Okay, bottom by 3 to get
6u minus 12v equals 42.
42. There we go. And top equation, of course, for now is 6u plus 5v equals 8. What do we want to do now, Brandon?
Change the signs in the top equation.
Top equation, all right, so negative, negative, and negative. Of course, the u's will drop out, giving me, this looks kind of ugly.
Negative 17 equals 36.
Careful.
34.
34. And that ends up giving me a V answer of what, anyone? Negative 2. Once I've got the V, I need to go ahead and get, Michael, our U. Let's plug in the negative 2 into the top. And, of course, multiply the negative 2 times 5 to get?
Negative 2.
Move that over as a?
Positive to get 16.
Ooh, careful.
Oh, negative 2.
Well, it's negative 2 times 5 is negative 10. Move it over as a positive 10 to get 18. There we go. So 6u equals 18, then u equals 3. But we don't write our answer as 3, negative 2. What is our answer, Genesis? negative a half. There we go. 1/3, negative a half. Questions on UV substitution? We all feel confident with that. Are you good? Okay, I wasn't sure if you were just dazed. I'm like, make sure she's good. All right, you're good? Everyone good? All right. Write this one down if you would, please. X minus 2y equals 17. X minus 2y equals 17. And 3x minus 6y equals 11. X minus 2y equals 17, and 3x minus 6y equals 11. What do we need to do on this problem, Kendall?
You can multiply 3 in the top.
To get?
3x and 6y equals 51.
All right. And then what, Kendall?
You change the signs in the bottom.
Okay. And that gives us
0 equals 40.
Thoughts, class?
No solution.
No solution. That's a contradiction. If you graph these, they would be parallel lines, which never intersect, so you don't get any answers. An inconsistent system. Questions on a no solution. Do we see the difference between this and the one where we get the parameter? Questions on this? Going once, one question? That's one question. All right. Write this one down if you would, please. 2x is equal to 10 plus 2y, and x squared plus y is equal to 7. And let's start with Audrey. What do we need to do here?
Okay, do substitution.
Yep, fine. Substitution is always good when one is quadratic. There's 2 ways you could approach your substitution. Well, 3 technically.
I guess you could. You're gonna have to divide both sides.
Okay.
So I guess get x by itself.
Okay, so knock a 2 out of everything in the top.
Oh, yeah.
All right, so if you knock a 2 out of everything, what does your top equation become?
X equals 5 plus y.
There we go. And now I could take a 5 plus y and plug it in here for an x. I don't really want to, but I could do that. What would be our other path that might be a little easier?
The y by itself.
Now that we've got the 2 knocked out, the y by itself actually doesn't look too bad, Kendall.
X minus 5 equals that.
Right, so now we'll put an x minus 5 in place of the y to make my lower equation, Abby, become...
Become x squared plus x minus 5.
There we go. Brandon, from there we need to...
That first one.
Not yet. We want to make sure we set the equation equal to
Oh, yeah,
0 first.
X squared plus x minus 5 equals 0.
There we go. Bring that 7 over as a negative, and then we'll backwards FOIL here. Genesis?
X plus 6, x minus 2.
And she's saying it, and she's second guessing, and she's doing the outer inner, and she's like
4 and 3.
4 and 3. All right, good choice. Hey, but the important thing is you get the numbers in there. If they don't work, you fix them. All right, so when each of these gets set equal to 0, I get 2 x values. We're used to seeing that, Michael.
-4 and 2.
And so, again, both of those are x's. Don't list that as a single point. Those are both x values. What are my y values going to be, Maddie? -9 and -2 as we plug in the -4 for the x, and as we plug in the 3 for the x. Questions on the quadratic system, or system with a quadratic in it? Questions on that? Okay, that's what we just did yesterday. Now let's do one more of these then. X minus y plus z equals 11. And 2x plus 3y minus z equals -4. 5x minus 2y plus 3z equals 38. And let's give the opening choice to Audrey.
You can get the z's by themselves. I mean, cancel.
Eliminate the z's, eradicate z's. All right, like DZs, but just anyway, whatever. Let's eradicate the z's. And let me get. I tried. Okay. How do we best get rid of disease? Wear a mask. Wash your hands. Take vitamin C. Anyway.
You can cancel the top two.
Yeah, if I put the top two together, it's already just going to cancel out to get.
X minus y equals 7 and 2x plus 3 equals -4.
And so therefore, what happy equation do we get, Brandon?
30x minus 2y equals 7. That's right.
Plus 2y. There we go. Don't want to mess up the happy equation and then we get sad answers.
Yes.
All right, then what do we need to do? Let's go to Maddie. Middle and bottom, okay. But let's put a, all right, to get. And then the bottom equation, of course, we'll keep the 5x minus 2y plus 3z equals 38. That allows the z's to cancel. And what is our second happy equation, Michael?
11x, 7y, 26.
All right, now what? Genesis? All right, so make a new system with the 3x plus 2y equals 7 and the 11x, oh man, plus 7y equals 26. Who makes these problems up? And now what? All right, so new system. That works out pretty nicely if we do what, Audrey?
If you change the signs in the top.
Yeah, let's go with the top there to get
X equals 3.
not bad at all. Then what, Kendall?
You plug in into the change equation.
Which one?
Top one. -1.
There we go, 2y equals -2, so y equals -1. Then what, Maddie?
You represent yourself to the top equation.
All right, so go back to the original. And we already know x is 3. We know y is -1. Of course, this says minus -1, class. So really it's 3 plus 1 or 4. Ditch the 4 as a to get. And so our answer is, class. Questions on 3 unknowns. We've done this for several days now and we feel really good about this. Questions at all? Let's take a look at one word problem together before we wrap up. Similar to the ones that we looked at, I believe, in our last lesson. Go ahead and read this for us if you would. Brandon.
At a local farmer's market, a person could buy 2 pounds of tomatoes and 1 pound of carrots for $30.75. At the same rate, 5 pounds of tomatoes and 3 pounds of carrots would cost $9.85. How much did it cost per pound for tomatoes and carrots?
All right, at your seats, go ahead and set up the system. Don't solve just yet. I want to make sure we've got the system set up correctly before we go ahead, but go ahead and set up your system of equations. Obviously, what are the two unknowns here, Brandon?
The price for tomatoes and carrots.
Good, price per pound for, what's it for? Tomatoes and carrots. And how should I represent the price per pound of tomatoes and the price per pound of carrots?
X and Y.
All right, so based on that, 2 pounds of tomatoes and a single pound of carrots is $3.75. 5 pounds of tomatoes and 3 pounds of carrots, $9.85. Is there anyone else who, like, the ES in tomatoes just looks wrong? I don't know. Spell check likes it, but I don't know. There is an E in yeah, but to me, I'm like, I'm with you, Michael. I don't feel like the E should be there. I like just put an S at the end. I mean, I don't know. Spelling was never my strength. I mean, God bless Noah Webster, but, anyway. So what is our system going to be here, Michael?
200x plus 100y equals 375.
All right, I would say initially the 2x, 1y, 375, but Michael's like, I'm just going to move the decimal anyway. Forget that. I'll go 200x, 100y, and 375, and that's okay too. Makes some really big numbers, but it knocks out the decimal. In that case, what's our lower equation, Michael?
500x plus 300y equals 985.
How many either had what Michael had or 2, 5, 1, 3, and then would still have the decimals in there? All right, questions on that? Technically, because all the decimals were at the end, not with the letters, you could leave the decimals there. That's not a problem. But maybe good to go from here, multiply the top class by 3, make this a, what do we get at this point? Abby?
It would make it 600x plus 3y equals 1,125.
Someone else get the same 1,100? I can't do it in my head that fast. Y'all like that number. Okay, so let's go with that. And then let's also go ahead and change the signs across the bottom. Well, but the old bottom, right? It's now top because I was lazy and didn't want to rewrite it. Cancel the y's. End up getting here, class. 100x is equal to, yeah, that looks right, 140. And when you divide by 100, all you're doing is moving the decimal back 2 places again. So x equals, class, $1.40, 1.40. Again, you could have just said 2x plus y equals 375. 5x plus 3y equals 985. Multiply the 3 to get a 6, 3, and 1125, right? When you put the negatives through, you end up getting a single x equals $1.40. So nothing wrong with working with the decimals. Also nothing wrong with knocking it out. Costs $1.40 a pound. For tomatoes, what do I do to go about getting carrots? Genesis? Where? I actually don't mind this one here. I don't think that's too bad because I can do 2 times $1.40 pretty easily. $2 times $1.40? $2.80. And then I can move the $2.80 over as a negative $2.80 and allow the calculator to do the decimals, right? Again, the key here is the decimals weren't with the x's and y's. Decimals with x's and y's makes things annoying. Decimals on the back end, we could probably work with that on the calculator. We end up getting y is, how much? 95 cents a pound. You can either do 95 cents this way, or you can say 95 cents per pound. Whichever of these, the other's more consistent. Questions on how to solve for a price per, like we see here? Any questions on this type of word problem? All right, you're going to get practice with other word problems in your homework this evening. Got a handout for you with 5 word problems on it. Do want to forewarn you, tomorrow, before we begin our exam review, we will be taking a quiz over all things systems. Okay, hence today's review. Okay, so a quiz over all things systems tomorrow. Let's help you with that. Making sure we're good to go on word problems. 5 word problems on a handout to do this evening. If you're watching on YouTube, of course, it's in the description of the video. Any questions at all on what we did today? That's just a few minutes before the bell's going to ring. Not enough time to take the quiz, which I was hoping to do, but didn't move quite that fast. You don't want to rush the quiz. I want to make sure you've got time to do well on it. Any questions at all on these systems? I feel like you've got this part of the exam at least. You do well on this. Obviously, there's more to the exam, right? It's not just a test. All right? Anything that scares us? Well, we've still got 3 minutes. Anything that scares us? Gavin, I can't hear you. You have to email me. Questions?
Gavin said the dark.
Gavin said he's scared of the dark. Well, he can turn on the light while he takes the exam. He's like, that would help. View the exam under black light. Anyway, any questions? All right, well, we'll end here. Then when the bell rings, you'll be dismissed. Have a wonderful rest of your day.